So we're going to look at graphing rational functions, and you're going to do a claims evidence reasoning for this. So first, we want to graph on Desmos, and I want you can sketch a graph if you want to, but just write down what are the x-intercepts. If there's more than one, that's fine. The y-intercept, and then I want you to guess where the vertical asymptotes are and the horizontal asymptote is. Okay, so guess on those. Remember, vertical asymptotes are the ones that are going up and down where the graph skips, like split your graph into pieces, into sections. Horizontal asymptotes, we're looking at end behavior. Remember, graphs can cross horizontal asymptotes, so don't freak out if in the middle they cross, because really, horizontal asymptotes talk about when x gets really big and x gets really small, what happens. All right, so this is your claim part. When you're providing the evidence, we're going to show how to find everything. So like for x-intercepts, we know that y is 0. And so we are going to set the numerator, the top of the fraction, equal to 0, and then factor. So I want numbers that multiply to be -8 and add to be 2. So that would be x plus 4 and x minus 2. And then I'm going to set those equal to 0. So I subtract 4, subtract 4 from both sides, and then on the second one add 2 to both sides, and I get these two x-intercepts, which I can put on the graph. So I have two x-intercepts at -4 and at 2. Oops. All right, so I'll put those on my graph. Then remember to find the y-intercept. I plug in 0 for x. So everything with an x is going to be 0. So I have 0 squared plus 2 times 0 minus 8 over 0 squared minus 25. So remember, it just leaves me my numbers, -8 over 25, or, sorry, -8 over -25, or positive 8 over 25. And you could change that to a decimal and put that on your graph. All right, then we need to find the vertical asymptotes and the horizontal asymptotes. So to find the vertical asymptotes, remember those are domain issues. So we're going to set the denominator equal to 0. So on x-intercepts, we set the top equal to 0, which means we plugged in 0 for y and got rid of the bottom. For y-intercepts, we plug in 0 for x. For vertical asymptotes, we're going to set the bottom equal to 0 because we want to know where it's undefined. So let's do that real quick. So the bottom is x squared minus 25. I'm going to set that equal to 0. So a couple of things. I can factor it, or I can, and I probably should have factored this to start with, so I'll go back and do that in a second. Or I can just solve for x. So x minus 5 times x plus 5 equals 0. So x minus 5 equals 0. X equals 5. X plus 5 equals 0. So x equals -5. All right, so those are my two vertical asymptotes. Those are vertical dashed lines that I'm going to put on the graph. And I usually just find the x-axis and draw those straight up and down at -5 and at 5. Now my graph is split into 3 pieces. Horizontal asymptotes, wow, that's really large. Horizontal asymptotes are talking about end behavior, and we use long division to find those. So I have x squared plus 2x minus 8 divided by x squared minus 25. So remember, what do I multiply by x squared to get x squared? Just a 1. So this is going to be x squared minus 25. There's no middle, right? When I multiply that, there's no x term. Change the signs, and this is going to go away. So I have 2x plus 17. Nothing I can multiply by x squared to get 2x. So y equals 1 is my horizontal asymptote. Okay, so I'm going to go back real quick because I was trying to hurry. But I probably would factor this before I even started. So I would go ahead and factor this into numbers that multiply to be -8 and add to be 2. So x plus 4, x minus 2 over, and then this is difference of squares, x minus 5, x plus 5. All right, let me know if you have any questions. Upload your assignment or however much you finish to Canvas. If you want to continue working on it, you're welcome to do that. Just make sure you upload what you have by Sunday night. All right, I'll see you guys on Monday.